This is how I built my cheap hot wire cutter, which I built from parts lying around the workshop and that I needed for my mast bearing project. The thing I bought was some Nichrome wire. For the power supply, I'd heard that you could use laptop battery chargers. I had one. Instead of controlling the voltage or the amperage, I decided to find the right length of wire that would give the right heat output. 270 millimeters was too short. 400 millimeters looked a lot better, but the wire still got too hot. 600 millimeters was just right. It cut the foam without too many fumes. I had some steel tube lying around from a trampoline that I could use for the wire bow and some wood for the base. I cut and TIG welded the tube, but you could use PVC for this part. I had some leftover epoxy flow coat and put a bit of black paint over the welds. The next day I put it all together and started testing it, and it was going really well. I made a device to cut circles and cut a cone. And another one. It was working really well. I was very happy with it. I got lucky because this was lying around. Someone gave it to me. They didn't have a use for it. I thought I'd never use it till I went to make this hot wire cutter. Now you might wonder how I adjust the squareness of it. I can adjust it this way by just sliding this clamp here. And of course I can adjust it the other way by just rotating the head with the half clamps that are underneath here. They allow it to rotate. Earlier on you saw that I needed 600 length of the wire. So it is 600 from down underneath there up over this little, you don't have to have a roller there, but I made a little roller there. And so that when the wire changes length, when it heats up, it maintains a similar tension. And then it goes along to the spring here. So that's up to that point there, from down underneath the base is 600. It did occur to me that the wire where it's attached here, you could have like an alligator clip where you could put the wire on at different places and you'd get different temperatures out of the wire. That might work. Also, these using these hose clamps come in really handy because you can just move it along to adjust the tension with the spring, depending on what spring you've found to use. And you might see that I've got this insulator underneath here, which wasn't really necessary because I insulated it underneath, which you'll see in a moment. I put one up there anyway. And because it's a steel arm, and you could so easily do this in PVC, many people have, you have to insulate it, otherwise when you connect the wires at the top and the bottom, the current will want to go through the arm, not the wire, if you know what I mean. So I only needed one insulator either at the top or at the bottom. I suppose if I'd have done it at the top, I would have had to use two insulators, one here as well. So looking underneath, just made up these clamps, which are very easy out of any old bit of wood will do. And the wire comes along, hooks up here on the other side. I did make these insulators, like I said, quite unnecessary. If you insulate the top, no need to tighten up this nut a lot. But the wire just goes around there in a loop. So it just hangs in there. The nut's just to keep it in place, not that it's going to move because it's sitting on that thread there. So that's what it looks like underneath. It's very simple, very straightforward, no switches except on the wall. I've intentionally got the wire at a length that it doesn't get really too hot, so you have to switch it off in a hurry. It does mean to say you've got to work with a little bit slower than you might if you could turn the temperature up a bit with a amperage or voltage regulator. But I just wanted something simple and quick as part of my project. So I hope you enjoyed the video, and if you did, please give it a like, please subscribe. In the next video I will have made a polystyrene mold, and I'm going to do some lost foam casting with aluminium. Thanks for watching.